All right, we're going to go back and do a little review from September, back into Prologue, doing our Intro to Earth Science. Remember, one of the most important things we talked about at the beginning was measurement. Way of expressing observation with more precision. Remember, you can't just use your senses if you want to be precise. Sense will give you an approximation, but you've got to use a tool of some sort if you want to get a more precise answer. All right, so when we take a measurement, remember we need a value, we need a number, and we need a unit to go with it. All right, very few things that we talked about in here will be just a number without a unit. All right, here's our types of measurements. All right, main things we measure: length, volume, mass, time, temperature, and how we measure, the symbol for each, and the tool that we use to measure it in. All right, metric system, all right, or SI. English system uses things like foot and ounce and things like that. What we're going to be doing in the metric system is we use a base 10 system. And we use the meter, the liter, and the gram, and then factors of 10 related to that. 10 times, 100 times, 1,000 times, et cetera, et cetera. And you can see the prefixes for each. So K for kilo, H for hecto, DA for deca, D for deci, C for centi, and M for milli, and then what they would look like if we were doing length, say. All right, rate of change, the speed at which a variable changes over a specific time period. We talked about four main types of graphs that we're going to see in here, or that we did see in here. One, we got both variables increasing. All right, that is a direct relationship. Whenever you have a direct relationship, your graph is going to have a positive slope. In other words, as x increases, so does y. Okay? Direct relationship. All right, next is our indirect, or inverse. Now we got, as the independent variable increases, dependent variable decreases. All right, remember, independent is your x, dependent is your y. So when you look at it, you're going to see a negative slope. Next, it's got a repeating pattern, cyclic. As x increases, y increases, then decreases. It's going to look like this. And then finally, your static or your constant graph, where you have a horizontal line. So we can say, what is the relationship between two variables? You could say they have a direct relationship. Or you could say as x increases, y increases. You could say it either way. All right? All right, graphing, rate of change. If we go back to our reference tables, okay, we see that rate of change is change in value over time, right? The only thing that might change is the time, okay? It doesn't always have to be time on the bottom, and I'll show you an example of that in just a second, all right? In this instance, our bottom number is going to be altitude, not time. Altitude, all right? What is the rate of temperature change? So rate equals, and we want to go from 0 to 2 kilometers. So we're going from here up to here. Okay? That is actually our bottom number. That's our x value. Okay, y over x, change in y over change in x. Our top number is the difference between the two actual values on the graph. So 75 and 55. It's going to be 20 degrees Celsius, so we're going to end up with 10 degrees per kilometer. Okay. Doing the next one, you notice something going from 2 to 4. Notice the slope of the entire line here is the same. That means you're going to get the same answer that you just got. Let's test it. At 2, we're at 55. At 4, we're at 35. So again, it's 20 degrees over 2 kilometers. So it's going to be 10 degrees per kilometer. But notice what happens when we go from 4 to 6. We go from 35 to 25. It doesn't drop down as much. The temperature doesn't drop. It only drops 10 degrees, not 20 degrees. The slope is not as steep, so your answer is not going to be as big. You're going to get 10 degrees, still 2 kilometers of altitude, so now it's 5 degrees per kilometer. Okay. 8, looks like 22 there. If you want to check it, there's your 8, 22, okay? So now we've got 3 degrees over 2 kilometers. It's going to be 1.5 degrees per kilometer. Notice our rate is getting smaller as our slope is getting more gentle. And then finally, we're at 1, 10 is 1. So we're dropping down 1 degree, 22 down to 21. 1 degree over 2 kilometers is going to be 1/2 degree per kilometer. So as our slope gets less and less and less, as the slope levels out, our rate approaches 0. If you had a perfectly horizontal line, your rate would be 0 degrees per kilometer. Let's move on. All right, graphing. All right, just real quick on graphing, just a reminder that the majority of the graphs we do in here are going to be line graphs. All right, we don't do too many bar or pie charts. We do a couple, but for the most part, we do line graphs. All right, so we're going to visually represent some data. We're showing the relationship between the independent and the dependent variable, right? Independent variables on the x, dependent variables on the y. Little example after we talk about this little checklist, all right? Appropriate title. Remember when we do a title, the effect of x on y. That works for everything that we're going to do. So you're going to label the x-axis with the units, plot the scale, label the y-axis with the units, plot the scale. Plot your points, circle them, connect them, and then if there's more than one on a particular set of axes, you want to give a key somehow, differentiate between the lines so people who look at it know what they're looking at. All right, here's an example. Okay, we've got depth on the left. That's our independent variable. We have basalt melting temperature on our right. That's our dependent variable. If we label our graph, there's our heading, right? Title, the effect of depth on basalt. It's always the effect of independent on dependent. Effect of x on y. Plot our depth, plot our basalt melting temperature, create the scale. Notice we don't necessarily have to have an origin, all right? We just have to make sure we cover our top and bottom. Plot our points, circle them, connect them with a line. Notice I've used as much of the graph as I think I probably could. You don't want to cram all your points and all your information down into one little tiny little corner of the graph. You're wasting graph and it can't be read. The purpose of graphing is so you can read the information. And that's it. That's it.